Hello dear students, in this lesson we are going to talk about powers or exponents. First of all, let's try to understand what are the powers or exponents. We can also call them as index, or in plural we can call them as indices. So students, whenever we have to represent a number multiplied for so many times, so rather than showing this expanded version, we can have a compact version which is called an exponential form, or we can also call it as a power notation. As you see here, 2 get multiplied for 5 times. So instead of writing 2 multiplied for 5 times, we may write it as 2 is raised to the power of 5. So in this way we can shorten our expression. And of course when we multiply, we'll get the same result. So students, in this notation, let's say we have 2 raised to the power of 5. So the number which is at the bottom, actually which get multiplied, this is called the base. And how many times we multiply a number, that is called a power. We can call it as an exponent, or we may also call it as an index. We have different names, we can call it like this. Let's take a few examples. Suppose we need to represent this expansion as a product as a power of 10. So you can simply count how many times 10 has been multiplied. It's 5 times. So 10 is the base because 10 is going to multiply it for 5 times. So 10 is the base and 5 is the power. So 10 raised to the power of 5. Whereas if we are already given a power notation, and we may be asked to represent it as an expanded form, or we have to figure out its actual value. So as we expand it, don't make a mistake like 2 times 3. 2 raised to the power of 3 doesn't mean that 2 get multiplied to 3. It means how many times 2 multiplied to itself. It's 3 times. So the power represents how many times it's going to multiply to itself. So it's for 3 times. So as you know, 2 times 2 is 4 and 4 times 2 is 8. So the answer is going to be 8 in that case. Students, there are many laws that we'll be learning in the upcoming lessons, but for now we have a few major important rules that we can discuss right now. Just like we have an example, 3 raised to the power of 5. So 5 is what? 5 is an integer and it's a positive integer. So whenever we have a positive integer raised to any base, it simply means that same number of times my base has to be multiplied. So just because it's 3 raised to the power of 5, you would multiply 3 for 5 times and you will get the result. At the same time, students, if we come across a question where the exponent or the power has a negative sign, means it's a negative integer, in that case we cannot multiply just like we used to multiply in the positive exponent or power. What we have to do in that case, we need to get the reciprocal of the base, and in that situation the power becomes positive. For example, if we have 3 raised to the power of minus 3, what we can do, we can take the reciprocal of this base, which is 1 over 3, and now the same negative power become a positive 3, and then you can simply perform simplification. It's just like earlier rules that we discussed. It's going to be 1 over 27. So this is how we can simplify a simple exponential notation, whether it has a positive integer exponent or even a negative integer. Then too we can simplify it. Let's take a few more examples or a few more rules, and definitely we'll have a lot of rules in the upcoming lessons where we'll be learning it as a separate topic. But for now we have a couple of more important rules. Just like whenever we raise any number to the power of 0, it looks weird but it's always 1. So let's say 4 raised to the power of 0, whatever, let's say it's 28 and then raised to the power of 0. So anything raised to the power of 0 is simply going to be equal to 1. Now again, there are some disagreements that we're not going to discuss right now. Some people say it's not defined, some people say it's just 1, but we can theoretically prove it, but that's not the case for now at your level. So you just remember anything raised to the power of 0 is always equal to 1. And of course, if there is no exponent or just a single exponent, that's equivalent. So say it's 5 raised to the power of 1, it simply means 5. Or even let's say we have 1108 and no power is applied on that. It means it has just one power, right? So in this way, one power isn't represented. It's understood that if a number is written, it has a single power. Let's quickly have a few more questions, students, so that our basics becomes stronger. Let's say we have to evaluate. Question is to evaluate these many expressions. So the first one is very simple. 4 is raised to the power of 3. It means my base 4 has to be multiplied for 3 times. And first of all, when I multiply 4 and 4, I get 16. And further, 16 get multiplied to 4, I simply get 64. So that's your answer. Now students, here in the next example, we have a fraction that get multiplied for 3 times. So just because it's the whole power, we can still multiply 2 over 5 for 3 times. So whatever is my base, the idea is whatever is the base that is multiplied if we have a whole power present, it simply means it's gonna multiply it for the same number of times whatever is the power. For now, 2 times 2 times 2 is 8, and when I multiply 5 times 5, that's 25, and further times by 5 becomes 125. So this is the answer. But students, look at the third question. Unlike the second one, here we don't have the whole power. The power hasn't got anything to do with this 5 which is at the denominator. So whatever calculation regarding the power we have to do is just on the numerator. So we have to apply exponent on the numerator but not on the denominator, because this 5 isn't given as a bracket or as a whole power. So sometimes you have to be aware of these things, whether the power is a whole power or just applied on a certain number. In that scenario, we just have this 8 over 5. 2 got multiplied for 3 times, but 5 hasn't got any power, so we keep it as it is. So yeah, that's it. And students, these were pretty simple questions at the beginning. In the upcoming lessons, we'll further discuss more about powers. See you in the next class.